This example here says, consider the action list class below. There is a class. Which design pattern is being implemented here? So now you see that in some cases, they don't ask you to implement SIngleton. They give you a class and the design pattern has already been applied and you just have to realize which one is it. And this is true for all design patterns. You have to be able to understand if it has been applied already. You should be able to look at the classes and figure out this is this design pattern. And for SIngleton, it's easy because it is the only design pattern where the constructor is being put under private. And then you know that this is SIngleton design pattern. So that's a very easy thing to figure out. And once you see that, you know that 3 other things or 2 other things happened. We made the constructor private, we introduced the static variable, and we also introduced the function to expose the instance. Everything else that is happening in the class does not matter. Okay, you don't have to worry about what about this, what about that. Ignore everything else. When it comes to SIngleton, it's all about these 1, 2, 3 things. That is all that matters when it comes to SIngleton. The destructor, you don't care about all of this. So the stuff in red, I'm saying you can completely ignore and just focus on what matters for SIngleton. And these are the 3 things that we have talked about. You can see that our class is called actor list. Our pointer here it is actor list, and here's our instance actor list, and our function in this case is called get actor list. It's not called get instance. Like I said, you can give this function any name you want. Why is the get actor list function static? 2 reasons. Because we cannot use the actor list static variable inside a non-static function. Number 2, because we need to be able to call this function without requiring an instance of actor list first. Number 3, write the necessary implementation code for this class. You do not need to include code for the actor size, get actor list functions. In other words, they are saying ignore all these other functions. Just focus on what matters for SIngleton. Even the constructor, you don't need to touch it. Remember, you don't need to touch it. In the implementation, whatever way it looks, it stays like that. The only thing that matters is in the definition of your class, it's now under private. That is what only matters. So when we now have to implement our get actor list class, there are 2 things to do. Number 1, let's define our variable, right? Actor list. But remember, it's a pointer. It's in the actor list class, and the variable is called actor list. And we can initialize this to an our value, right? And what I'm referring to here, since it's not on the screen anymore, is this part here. Our variable is called actor list. Okay. Pointer of type actor list. Now, the second thing we want to do is the get actor list function, right? Remember, in the implementation, you don't use the keyword static. No, you just do your thing. So it's actor list inside our class actor list gets actor list. And in here, it's a very simple if statement. If actor list is equal to a null, then actor list equals new actor list. You call your constructor and then return your actor list like that. One other thing that others do when it comes to static variables is they also always prefix them with the name of the class. So they always do them like this, actor list like that, but it doesn't really matter. So this is also correct syntax-wise to prefix a static variable with the name of the class, but it doesn't really matter. You can just not do it if you don't want to, like this. This will also still work fine. But basically, that's it. That's how you do your implementation of your class, and you're done. Okay, let's look at another example of SIngleton. SIngleton is really easy, guys. You can apply SIngleton very easily. Consider the following class definition and answer the questions below. Okay, here's a class definition. Please note that this class does not have a purpose other than to access or to assess your understanding of the SIngleton pattern. They're saying this class is useless. It's just there so that we can see if you understand SIngleton, right? Now, inside this class, there's a static variable called name. It doesn't matter that there's another static variable called name. Remember what I said, a static variable is declared twice. For a declaration, here's the actual declaration. So it doesn't matter. It's just a static variable. You just have to know how static variables work. It's shared across instances. So in terms of singleton, this does not concern you. It's some of the stuff that's going on in the class that doesn't really matter for what you need to do. Okay. Anyway, the question then says, what is the purpose of the singleton design pattern? In which ways does the above class comply and not comply with this purpose? So the purpose of the singleton design pattern is to restrict the number of instances of a class or to ensure that there's only one instance for a class across the board, right? That's one way you can put it, or to restrict the number of instances for a class that can be created, whichever way you want to go with. Anyway, so does this comply or not comply? No, it doesn't comply. And in which way does it not comply? The constructor is too public, which means people can create many instances of this class. Let this not confuse you. Okay, it does not comply at all because the constructor is not private. We don't have a pointer to store the one instance that we need, and we don't even have a static function to return the instance. So in other words, you're explaining the three steps that you should do to get singleton for this question. Constructor is not private. We don't have a static pointer to store the instance. We don't have a static public function to return that instance. And that these are ways this does not comply. Now, if you had said it complies, they didn't, in this case, they didn't ask you to convert it to singleton. They simply say, does it or does it not comply? Anyway, the next question then says, write code that creates two instances of single A class and illustrate that they have the same state. Whenever you talk about the state of a class, you're referring to the values of the data members under private. So you're saying make two instances and show that they've got the same value. In this case, yes, they would have the same value of name, not because it's singleton, because it's static. This is not singleton. This is just normal static variables, right? That's how they behave. That's how they work. So they are saying show that they've got the same state, just show that they've got the same name, right? So in this case, you're just demonstrating how you would do it. Write code that create two instances of single A. Oh, that's easy. I've got single A. I can call this one A1. Or you can do this on one line if you want, even. A1, comma, A2. I've got two instances, or on two lines, single A, A1, single A, A2, right? So I've got two instances. And show that they've got the same state. So in this case, you can use your set name function. So you can then go A1 dot set name to ABC, right? And then you can then display however way you want to display. The purpose of this code is to just demonstrate that A1 and A2 we have the same state. So I can use at this point, you can then just explain that A1 and A2 we will have the same value. So if I do something like qdebug here, and I go A1 dot get name, and I go A2 dot get name, I just need to show that they both have the same value. So I can then say both this statement will display the same value, or will display ABC for both A1 and A2 because it's a static variable. It doesn't matter that you set name using A1. If you say get name on A2, you would get the same value because it's a static variable. It's shared across instances. In other words, both A1 and A2 are using the same name instance, which is the one that was declared here. It sits outside the instance, okay? So 5.2 is just there to demonstrate, to let you demonstrate that you understand how static variables work, okay? So in this case, you can do it whichever way you want, but you're just whichever code you write, what's important is to show that I know how static variables work. They'll have the same value. 5.3 says rewrite the class, calling it single B so that it complies with the standard structure of the singleton pattern. Now, if you had said yes, and we get here, then they say, now make it comply. Obviously, you'd go back and be like, no, it doesn't. and then you don't know how to do you don't know how to do 5.3 because there's no way you say yes here and then you go here and then you know how to do 5.3. No. Okay, single B. So now they are saying make single B singleton, right? What matters, you can still keep these, these functions here. It doesn't matter. You can still keep them there, set name, get name. You can still make this one static, but if it's going to be a singleton class, it doesn't really have to be static because there's only going to be one anyway. There's going to be one instance anyway. Okay, so what I can do in this case is I can then go single B, right? Class single B. In here, under public, I can still have my QString get name. I can still have my void set name, QString n, whatever it is. Then under private, then now I can apply my singleton. Let's hide the constructor, single B. Let's introduce a static variable, single B, instance or only instance, whatever you want to call it, instance, anything. And you can still have your Q string name is still here. And I'm saying it's redundant at this point to make this guy here, to make this thing here static, because there's only going to be one instance for this class. So you don't really have to make this class, this here static, because there's only going to be one instance anyway. So there's going to be one string anyway, right? And then obviously under public, you need your, I forgot N here. You need your static single B get instance function, and you're done. And I've applied singleton because I have, in this case, here's my public function, here's my constructor, here's my instance. The reason why this is static, it shows that you understand what it means for a class to be singleton. And they are saying it doesn't really matter if this is static anymore, because the reason why this was static is because we wanted there to be one name regardless of the instance. But now that there's always going to be only one instance, it doesn't have to be static anymore because there's going to be one instance of single B available everywhere, right? So if you still make it static, I don't think you would be marked negative. I have no idea, but it also shows you don't quite understand what you are doing, okay? But still you get marks for at least making it singleton, right? Right, so let's look at 5.3, that's how you do it, it complies now. Now 5.4, write code that attempts to create two instances of single B and illustrate that they have the same state. So in this case, we still have the same state. Why? Because we still only have one instance. So in other words, what's going to happen here now is I'm going to have single B, A1, A1 for instance, but this is now going to be equal to single B dot get instance, right? And I can do this for the next one. I can have A1 and I can have A2. Then I can do something like A1 dot set name to ABC here. But because it's all one instance, if I then go A2 dot get name, it's exactly the same instance. So if I then go if I then display these and go A1 dot get name, and I also go A2 dot get name, I can then explain that both A1 and A2 will show the same value for name because it's one instance. That's how you can then demonstrate your knowledge on 5.4, right? So in 5.2, the reason why we had the same value for the names is because the name is static. That's why, because a static variable is shared across instances, it doesn't matter which instance you use, it's the same one. So in this case, we have two different instances, only that they share the name because it's static. Therefore, it will be the same across the board. But in this case now, we've got one instance, two variables, but it's one instance. under the hood, it's just one instance. So it doesn't matter if you say set name here, it will be this, it's the same instance, right? So therefore, it doesn't matter what you do where, you get the same values regardless of which variable you use to set the value. And that is an example of SIngleton Design Pattern. Now here's another question. Consider the partial definition of the class Solo that implements the SIngleton Design Pattern. Write one line of code to demonstrate how client code can access the only instance of Solo. How do you get an instance of Solo given such a class like this one? This is exactly like in the previous video where I demonstrated how to do Singleton using a class called Solo. So this is an exact, a direct application of that example that we use. So we are going to go Solo s equals Solo dot instance. Here your function is called instance. That is the one that you use, which is this function. Done. The following lines of code that use Solo do not compile. Why? Because line 1 is attempting to create an instance of Solo and then using that instance to call the instance function. The reason why it doesn't compile is because this line here is attempting to create an instance of Solo, which is not possible because the constructor of Solo is private. So this here is not possible. Okay. Why is the pointer one instance to the only instance of Solo static? Because it must be instance independent. This pointer must not belong to any particular instance. It must not be owned by an instance. What is the effect of adding a destructor in Solo, which has the statement delete one instance? An interesting question. So what they are saying here is, if we go inside our class Solo and we add a destructor here that deletes this instance, what is the effect of that? Now, consider doing this. Let's say we've got two variables here, Solo s1 equals Solo dot instance, right? And then we make two of them, right? Now remember, all these ones are using the same instance under the hood. Now, if you then do something like delete S1, right? And Solo has a destructor, it means this statement is going to delete only instance. But only instance is the instance being used by these two. So in other words, it will delete the one instance being used by other variables. Okay, so adding a destructor will cause the only instance to be deleted, and it may be maybe it will be in use somewhere else, right? So you don't want to do that. You don't want to add a destructor inside a singleton class because it will delete the only instance, or it will delete one instance, and it may be in use somewhere else by other variables. Okay, so that is your question 5. So I think you can go on and on with singleton class examples, but otherwise this gives you a basic idea and understanding of how the singleton design pattern works. And you just need to practice, obviously, during our classes. If you find more questions that you want us to discuss on singleton, feel free to join us on our platform, ivtutor.com. Otherwise, that is it from me today. I'll see you again in the next ones. Cheers.